start. I guess we are 5 minutes too late. Sorry for that, because the laptop messed it up a bit. So I welcome you to my talk about static versus dynamic stream processing. Maybe I should edit the underline streaming from a business perspective, because I try to show why certain features in the stream processing framework are, from my or our point of view, are crucial for the adoption of stream processing in a wider business context. So what I'm going to talk today about is, first of all, myself. I'm going to introduce myself, the company I work for, the department I work for, so you give a rough understanding of what we do and what kind of setting this stream processing frameworks are applied in. Next, I'm going to show you the first encounter of stream processing at the Otto Group, or the first projects that we did with stream processing frameworks or streams as such. Talk a bit about the increasing number of use cases that came to us when we first produced our results. Show some implementation issues we had and why we finally decided to use, let's say, a more generic stream processing framework, and which finally led to the decision to implement our own framework called Spooker. And then, in point 7, going to be the way back to Flink, or the way back to, let's say, community-supported, broader-used frameworks. And in point 8, would like to talk about the future I'd like to see for Flink or streaming as such, and finally give you the chance to answer any further questions. Okay, so about me. My name is Christian. I do work for the Otto Group in Hamburg as a senior software developer and architect. Actually at the business intelligence department, where I'm the tech lead for the real-time stream processing framework. So the Otto Group, who isn't there on the lightning talks today, is the world's second largest online retailer in online retail and end consumer business. I shouldn't just simply copy and paste, but okay. And we're Europe's largest online retailer in end consumer business when it comes to fashion and lifestyle. So our whole business is set up on 3 pillars. First is multi-channel retail. We provide catalog business, e-commerce, and over-the-counter retail. For example, in Germany, we run Otto.de or Bonprix.de. Sportcheck, for example, has e-commerce and brick-and-mortar stores as well. I think there's a large one here in Berlin as well. In France, for example, we have Trois Suisses, in UK, Fruman's Grattan, and in the US, for example, Crate & Barrel. Aside from that, we provide financial services which are aligned along the value-added chain, like credit card processing, credits, etc. pp. We've got at least the service pillar, which is made of logistics, mainly warehousing, transportation, ordering, and stuff like that. I work for the business intelligence department, which is sits on top of the group. So we provide service to all our companies, which are at least around about 120 numbers. We provide BI strategy for the group and for the single companies, consulting, for example, in talent recruitment, training, networking, and such. But we also provide business development, like the evaluation of business models, which are mostly data-driven. And from a technical perspective, we run a large or operate a large data pool, where we try to, or where we collect and try to collect data, and we try to figure out whatever, for example, what users do on our sites, how they behave, build services on that, and that's our last stake in that. We provide software as a service solutions, like, for example, fit predict services, where you can purchase a shirt in, let's say, XL, and in the winter you need a pullover, and then the system tells you, well, you should buy that on XL as well, for example. We are dedicated to open source. We have actually 3 projects running, which one is the Scatoscope, which provides scheduling service actually and specifically for Hadoop clusters. Palladium, which is an, let's say, runtime framework or full-fledged framework for running machine learning solutions. It provides, for example, A/B testing capabilities and training and whatever. A/B testing capabilities. And finally, we've got Spooker, which is a stream processing framework we're going to talk about later on. So the first encounter of stream processing in our department was in combination with unified tracking. We have these different sites that are actually, I think we collect data from around about 100 sites, and we anonymize them, unify them, and then we start to build up dashboards, management dashboards. For example, how is the traffic on specific sites, on specific dates, specific devices, whatever. And we implemented this simply by providing a template to the companies, and where they started to implement tracking pixels. And we receive these data from their sites, and they are getting unified. The problem is, how do you ensure that all these 4 pages are implemented or tagged the same way, so you have consistent metrics? And our first, and it is the first approach for the first implementation step. We have a bunch of people sitting there and clicking through the sites, checking their website, their web browser logs for this tracking pixel call, and check the parameters and say, okay, this applies or this is compatible with this tagging guide for page detail views, for example. And so they do this for each site and check if everything is consistently implemented. The problem is, what happens if this page changes? You have to do this all again. And all again, and all again, and all again. And if it comes, for example, to continuous delivery, and you change your site quite often, it is a hell for these people checking this site. So we finally used the event stream that the tracking provider provides to us, where we can read each event generated on the left side with a latency of around about 3 seconds on the right side. So what we did was we took these events, incoming events, figure out which event type it is, and then we started to evaluate the data we received against the template, and say, okay, this is not okay. We assume that the event type at least is set to what we expect. So if this is messed up, you will have to do manual work again. There was an Akka-based stream processing application, quite simple. Attached ourselves to this WebSocket, collected data, processed them, and pushed them out to the database. And then finally, people came up and say, well, if you can do this, maybe you can fetch us some customer sessions, search sessions. Maybe we can do some sort of dynamic profile selection, like we would like to know how many female customers are surfing a specific site and searching for red shirts during noon or whatever. Another idea was to do user agent identification. I talked about this in the morning. And finally, someone came up and said, okay, why, if you do all this or have all these requests doing this site on these things on the left-hand side, why don't we do dynamic stream queries? Okay, and then our problems began, because we figured out that the way we implemented these stream processing application or stream consumer is very resource intense, because you need developers, you need ops people, you need business guys, whatever, and it's highly time consuming, and it's a rather static implementation. You don't have any flexibility. What you do is you build static topologies on dynamic data in a very highly flexible context, and that is, you don't want to do this if the number of applications rises. So and then we asked ourselves the question, okay, what do we need if we want to have a stream processing framework? So we need, this is just only a selection. Alex called us tomorrow, talking about this tomorrow again, and he's probably going to extend this a bit. So we wanted to have a unified runtime environment. We didn't want to figure out specific aspects for each job that we implement. We wanted this framework to be easily extended. Operation support must be provided. It should have a steep learning curve. Support for multiple sources and things so that we can connect to different systems and read data and push data to various sources and things. And we wanted to have real stream processing, not just mini batching. So and then we thought about, okay, well, we could do this, but if we want this to be very successful within our department, we need to have a different perspective as well, and that's the business way. So we check how is the business working with data. And the first idea is, when that came up was, okay, they are writing their SQL statements, executed against the database, and receive the data. So that's a typical way how these guys work. So we need something which is somehow similar. It doesn't have to be SQL, but something similar. So there needs to be no code deployments. It must be self-dependent and immediate deployment. So saying that they shouldn't write something down, come to a developer or ops guy and say, okay, I need this to be deployed, and maybe you can do this on yesterday. And what we also needed is constant redeployments. Because if you just write down a SQL query and figure out, okay, there's some data, well, maybe there's one attribute somehow messed up. Okay, I need to rewrite this query and fire it up again. So we want to, or we need this as well for stream processing, because if you can't support this, you're again in this constant loop between business talking to ops. And we need somehow a consistent monitoring. Saying that we don't want highly technical monitoring, like, okay, see there are some bars and lines and everything is cool and there's green and red and whatever. But I want to, if I take the business perspective, I would like to know what happens in my topology at a specific point. If for example, no data is available at the end of this topology. Why? I can't do this from a business perspective. I can't do this if I just simply look at monitors and dashboards and tech dashboards. I can't say, okay, this is, for example, a missing piece within this topology. So what we need is somehow a mixture between the representation made by the business and the monitoring data collected and visualized by the ops. So perfect match would be to have both in the same representation. So finally, what we wanted to have is dynamic topologies or queries on dynamic data in this highly flexible context. So now we took all these requirements plus all the others that we had, and finally figure out that these in the middle, this with the yellow cross, are missing. We're missing. So and then we finally we evaluated different frameworks like Spark, Pulsar, and so on. And Flink wasn't available back then from a streaming perspective, or let's say it wasn't that mature, so we didn't took a look on that in that moment. So we finally decided to write our own framework, which is called Spooker. It was ASAP, but ASAP was used by Amazon, so we had to change a bit. We took this funny thing. So we focus on three different aspects. So first of all, library deployment. Compared to, for example, Spark or even Flink or any other framework in this context, we didn't want to deploy any code when starting our topology. So therefore, we needed something to deploy, or some support for deployments before executing the topologies. So if you want to use anything, you need to deploy it before using it. But what you can use it afterwards simply by writing down a configuration, so that you have zero code topologies, which may be used by business departments. So and that finally leads to what we call ad hoc queries, so that you can immediately adjust and queries, fire them up, adjust them immediately afterwards, and you receive, and you have very short feedback circuits. The code is still available on GitHub, so if anyone is interested in taking a look on that. And this is the, let's say, very, very high-level overview. What you see here is we have this this cluster of different nodes which are running a node having some inputs and some outputs. These may be, for example, connectors towards Kafka, or I don't know, FTP, file syncs, WebSockets, whatever. Before you can use anything, or before you can execute any topologies, you need to deploy the libraries containing the component, the implementations, for example, filters or different operators. And then you issue app request, which contains the topology, and then that one gets distributed and executed on different nodes, depending on what you configured. So I can show you this. I hope it works, because I had to switch off this guy. Okay, no, I need to show these one. Okay, this is a rather, let's say, not so business-friendly representation. So what you see here is it's a simple pipeline definition. You define queues, so the idea is that you can use different type of queues. For example, if you would like to interconnect different operators within a pipeline, you can use file system queues, you could use the memory, you can use Kafka, whatever. And then you have different components that you define afterwards, tell them where to read from and where to write to. In this case, we don't read from any queue, but we retrieve data from this tracking provider. And we simply write it to a Kafka output. It's a very, very basic one, because I wanted to keep it simple. And then we fire it up. In this case, we use the REST API. Cross our fingers that the network works. Something happens. And you should see something happening over here. Yeah, okay. So it is that simple. These are tracking data. Okay, so the idea was simply to enable people just to publish these topologies or these queries and fire them up and get it executed. So, and why we think it is important to have these at least five aspects is that you if you have a no-code topology definition, you have a very steep learning curve. You can get people work with your framework very, very fast and produce results very, very fast, and you get very well. It gets adopted very, very easily. You can focus on functionality instead of implementation. Well, if you implement your topology, you have to test everything and write on and whatever and write code a lot. And what you don't do is focus on your functionality. Well, you do it at least by implementing this, but somehow the focus is a bit differently. And from my point of view, you have a better representation because you don't have this bloating glue code all around. If you can deploy these topologies on your own, you don't have that much need for resources like ops and developers and whatever, and you get shorter time to execution. And you're very independent, and you can use it from your office desk and just ramp it up and receive results immediately without needing to talk to the tech department. You get immediate deployments, so get a very, very short feedback circuit, so you can see mistakes, for example, much easier, or failures much easier, so that you can easier adjust your pipelines. And what you get from these shorter feedback circuits is that people are willing to try out new ideas more easily, so that you get your people who work with the data, and that's very crucial when it comes to business. Because you're only better if you if you understand your data much better, and you learn from your data if you use it. So in that case, it's if you enable people to use it, they will be produce probably much better results. And regarding the consistent monitoring, from my point of view, it is easier to communicate between the ops department or the ops people and the business people, because they have a common notion of what they are talking about. They don't talk about fancy dashboards with green and red bulbs and whatever warnings and any error messages. On the other hand, there's someone who says, okay, I want this user and that shirt and whatever, but they have a common understanding because they see the same representation, and the ops guy receives all the information that he wants in this visualization, for example, and the other one sees, okay, there's something happening. I don't understand what is over there, but there's something red, and yeah, I may understand what's the problem. So, oh, there's something missing. Okay, so and in 2015, in the beginning of this year, we thought about challenging our approach versus or against other prominent approaches at the market. So we did another evaluation, and we evaluated our framework against Pulsar again, Spark, Flink. Yeah, and I think it was SQL Stream. And we finally figured out that especially Flink did a very great job, because they seem to be, or no, it's more like seeming. It is a great fit when it comes to all the requirements that are underneath the hood, if you take out all this ad hocness and whatever what we thought about. So they implement everything that we were lacking in the moment, where they have all the nice operators and delivery guarantees, cluster support whatsoever. So what for us would have meant a lot of work to do. And so we finally thought about, well, why don't we try to adopt Apache Flink for our use cases and incorporate our ideas on how we think we should work with streams. And being here, I think some weeks ago at the Data Artisans office, they finally pointed us to the right place. We were somehow where we were experimenting with this framework, and then we came to the idea, okay, let's do something. Let's implement some monitoring aspects. So they pointed us to the right place, and it's finally, I must say that it's all there. You don't have to do any magic to incorporate these ideas into this framework or into the ecosystem, because it has, for example, a very nice Akka interface at the job manager, which you can use to interact with this with the framework. So, for example, you can query the system for running numbers of registered task managers, number of available slots. You can submit jobs, you can cancel jobs. So it's everything there that could be of interest. Writing some additions to this, and yeah, what we did was there was the first approach, because we wanted to have this or implement this consistent monitoring and somehow a short feedback circuit, and we utilized the accumulator API for that one. So what we did was wrote our jobs, defined a consistent way of exporting data through the accumulator API. I'm going to show that in a moment. And what we did was wrote the Flink metrics collector, which simply spawns a manager to collect or query all the running jobs, which again spawns a new metrics collector for each running job, which then receives all the accumulators and forwards them on to our Graphite system at the moment. So this is part of the implementation. So it's quite simple. It's very easy. You just simply push this recurse running job status message towards the job manager and start receiving the information that you need, and then you take the the running jobs, extract those that you don't aware of, that you're not aware of, and then start the metrics collector for each of them and start collecting your accumulators that you can, where you can extract then values from generated from your jobs and do whatever you want to do with this. First of all, I'd like to show this one. Yeah, it's a very, very simple example. Here you see the different accumulators defined. Here they are bound to the context, and then this application, this function is called over and over again. It simply, what is it? Generates random numbers. And if we take a look on the job metrics executor, we're going to probably release this as open source soon. So therefore, I'm going to give you just a brief overview. So this is no, sorry, I need to start with this. This is the entry point where you query the running jobs, receive them in, well, I don't know how many seconds, I think it was 1 or 2 seconds. It queries the job manager for these information and receives the response, which is then handled over here, and it starts a new actor of this type for each new job, which then by itself requests the job manager for its own state every n seconds, which are then, in this case, simply added to the metrics registry, which can be then forwarded towards our Graphite installation. So we can start this one right here, and there, see it happens. Nothing happens. And if we start the application, it takes a while. And then you see the numbers. So and if we stop the application, I'm going to skip that right now, the one stops again. This application stops to collect and visualize this data as well. And this is simply configured to produce the data to the console. You can even forward this to for example, to Graphite or any other application to visualize your data. Okay. So how to move on? Now that we finally received our metrics, this is taken from NiFi. Anyone knows NiFi? Yeah, okay. So what you see over there is a topology defined in NiFi, and NiFi allows allows to visualize certain data from these operators here. You can't see this over here, it's too small, but it shows you, for example, the number of messages inbound, number of messages outbound, the number of bytes inbound, whatever. And this is actually the pre-step over here that we are currently working on for this bigger picture. And then the next idea is to define topologies using a similar UI, for example, maybe even NiFi, if that works somehow, and deploy this one to the cluster so that we have a sort of a loop, so that we can receive the metrics back and visualize them in the representation. And having said that before, it's all there because you got this ACAF interface. And we also had some discussions where to place this one. The first idea was to implement this or to extend somehow the job manager, but we finally figured out that it's too much modification on the framework, so that could lead to problems if a new version comes out and we need to migrate everything, and we didn't want to do this. And the same applies to the task manager. So finally we figured out that starting and stopping jobs, for example, can be done with this API as well. So we're going to focus on the client or this API that I just showed to you, so that we can finally implement the missing three parts down there. So no code topologies, self-dependent deployments, and immediate deployments. So why is this so relevant? For us, from a business perspective, we have Hadoop on the static data and static queries. You can write down your query or program your query as a MapReduce job or whatever, and execute it on this static data. You can have Spark, for example, on dynamic data and static queries. Static means in this way that you have to program your topology and execute it. You have to produce code. And what we took as a blueprint was the idea of SQL, because the lower right was still missing, because you can query these data, you can do this. This is fine from my point of view. This is not so fine because you have to deploy code somehow. And over there, I think it's the best solution. You have a very, very easy to understand query language, more or less, and you can execute it immediately and get immediate results. So that's something missing down here. And from my point of view, Flink seems to be the best fit for that, extended by what we're trying to implement in Spooker. And the Apache Zeppelin project, for example, points into the right direction using this Python similar notebook approach, and maybe there's something coming up. It doesn't really look like this logo. It looks more like a bug, right? Okay, get this one away. Okay, last slide. Obviously, we're hiring. If someone is interested in working in a e-commerce environment with very interesting data, very interesting projects, very interesting people, you find a link down there. Feel free to apply. Okay, that's... Any questions?
Just an additional question about the Spark versus Flink thing there. You said static queries for Spark, but with the data frames API and the SQL queries you can send to Spark, wouldn't
Sorry?
that?
I don't understand.
So I'm just asking about one of the last slides you showed, talking about static data and static queries. And you showed that Spark has static queries, but if you were to use the new data frames API and the SQL API it has, wouldn't that also be dynamic in that case?
It was just an example, so
okay.
Just to show the idea behind that, because you need to write down your code and deploy this jar. So that's what, from what I understand, on the static, because it's static for the business side. Yeah, you don't simply just write down anything and deploy it and get immediate result, but you have to program something, package something, deploy something, monitor something, whatever. So this is very, very static.
But if you were to simply have like you send the SQL text as an argument, you have no need to deploy anything, and then it would be dynamic, right?
Yeah, somehow. So from that point of view, it's if you take, for example, Hive, it's dynamic as well, because you simply write down your query and then get it distributed. Yeah, that's right. But
okay. Yeah. Thanks.
I think over there, left or here.
Who wants to be first? Hello, my name is Tom. On one slide, I saw Mesos, the framework Mesos. Could you please elaborate more on this?
Not really. That was work in progress. But actually the point is with Spooker is that if you would like to deploy nodes, you have to do it manually actually. And so the idea was simply to use Yarn or Mesos, and as we are using Mesos, in our cluster as well for certain aspects. We thought about integrating with that, and we experimented that with this. So it was work in progress.
One more question? Okay, thank you.
Okay, I would like to add something. Just if anyone was here from at the talk at Slim, I think he was right when saying that that the community needs to push this forward, get out and talk about this, because it's important, because it's much better than any other frameworks I've worked with today and up to date. And it's a very nice framework. It has very, very nice features, and so don't lose this and push it forward. Okay.